everybody, it's Ms. Calkins, and we are going to continue our quadratics unit today. We're going to be focusing on some characteristics of quadratics. There's several vocabulary words, and again, everything that I'm going over here with the video, I'm also posting notes of everything on Canvas, so you can look on there and see all the examples and things written out, maybe a little bit more detail than what I'm going to give you right now. Okay, so just to review the definition of a quadratic, it's a function that can be written as ax squared plus bx plus c, where this leading coefficient cannot be 0. So it has to be a positive number or negative number. The graph of a quadratic is called a parabola. So the first thing that we're going to do, we're going to create a graph from this function. I created a function table, and remember, all of these x values are numbers that I just came up with. In order to get your y value, we're going to take each one of these x values, drop them here, and also put them here. You have to put your x values everywhere that you see an x. So when you put negative 4 right there, that's going to be negative 4 squared, which turns out to be positive 16. When you put negative 4 there, so I'm just going to give you a couple of examples, and then I'll fill in the rest. When you put negative 4 right there, that's going to give you a positive 16. 2 times negative 4 is going to give you a negative 8, and then you have that plus 1. So when you have 16 minus 8 plus 1, when you put in the negative 4, your output or your y value is going to be a positive 9. Then we would do the same thing with negative 3. When you put negative 3 into the equation, negative 3 squared is positive 9. When you put negative 3 right there, that becomes a negative 6, and then you add 1. So 9 minus 6 plus 1, that would give you a positive 4. And then you could do the rest. You can just drop them in there. I'm just going to go ahead and tell you what they are. When you put in a negative 2, you get a positive 1. When you put in a negative 1, you get a 0. When you put in a 0, you get a 1. When you put in a 1, you get a 4. And then you get a 9. Now, one thing I want you to notice, we could do the first difference and second difference and prove this is a quadratic. But also, you've got 9, 4, 1, 0, 1, 4, 9. So there's kind of a pattern there that you can see where the numbers are going to repeat. So over here, I have sketched out a graph. You can use Desmos graphing calculator. You can type this equation in just like you see it, and it will give you a really nice graph on Desmos graphing calculator where you can see some of the key features we're going to be talking about. So when you have your negative 4, 1, negative, and again, I'm sketching this out so it's not going to be perfect. There is negative 4, positive 9. Here is negative 3, positive 4. Here is negative 2, positive 1. Negative 1, 0. And then you have 0, 1, 1, 4, and 2, 9. So if you notice, it's symmetrical, and this graph is kind of like a U shape, okay? So this is what a parabola looks like. So when I graph these ordered pairs and I graph the quadratic, I get this shape, and that's called a parabola. So now we're going to be looking at some key features of a parabola. First of all, you're either going to have a maximum point or a minimum point. The way this graph is shaped, you're going to have a minimum point. There is not a maximum point. I'm going to show you in just a second an example of what a maximum point would look like. This one's going to be a minimum point. It's obviously the lowest point on the parabola, and you would cite the minimum point as an ordered pair. So for this parabola, it would be negative 1, 0. For this example, there's actually no maximum point. Your axis of symmetry. Okay, and I actually have the definition written on this paper, and there's an example on Canvas that you can go back. The axis of symmetry is a vertical line that you draw through your parabola that splits it into 2 equal points. And that vertical line is going to go through your vertex. So your maximum and your minimum point, this is also going to be known as your vertex. So if I draw a vertical line right here, that is my axis of symmetry. Now, the way you cite the axis of symmetry, you're going to cite it as an equation. So the equation of this vertical line would be x equals -1. Remember, if you have a vertical line, it's going to be x equals a number. Okay, so a couple of other things. If A is positive, like in the example we just did, if A is positive, your parabola is going to open up like this, where your minimum point is here. If your A value is negative, as in this example, your parabola is going to be shaped the opposite way, and this is where you would have a maximum point, not a minimum point. So this is the minimum point, and this is the maximum point. So it just depends on which way, if it's concave up or concave down, which way your parabola is going to open up. And again, my axis of symmetry would go through there. Your vertex is going to be your highest point or your lowest point. Sometimes you have a parabola where it's kind of split in between 2 points, and if that's the case, you've got to find the average of those x and y values to get that true vertex point. I will be available in Zoom for this section. Our Zoom meeting for this section is going to be at 12 o'clock, not 11 o'clock tomorrow, because I have a faculty meeting that's going to conflict with our regular time. So I will be available to you from 12 to 1 tomorrow. So please rewatch this video if you have any questions. Go to Canvas and take a look at these notes. For your assignment today, you just have a couple of quadratics that are going to be like this. You can graph it by hand on a piece of graph paper like I did, or you can put it in Desmos Graphing Calculator. You're going to have to answer some questions for me, like what's the maximum if there is one, what's the minimum if there is one, the axis of symmetry, where's the vertex. So your vertex is going to be the same as your minimum point or your maximum point. And then there may be a couple of other features. I think it might ask you if it's going to open up or open down. I can't remember. Anyway, if you have questions, please come to see me in Zoom. I hope you guys are doing well. I miss you, and I think about you every day. Bye.